Well, we're ready to start Chapter 2. Chapter 2, we're going to study quadratic functions. Let's first of all look at the definition of a polynomial function. You can see it listed there. F of x equals a sub n x to the n, and so forth out to a sub 0. One variable, namely x, and the a's or coefficients are real numbers. A constant function is something like f of x equals a linear function, which we already studied and you're very aware of. Let's look at some examples of polynomials. Our first example will be x to the fourth minus 7x cubed. This is a fourth order or fourth degree polynomial. Our second example, x cubed minus 8. This is either called a third order or a polynomial of degree 3. X to the seventh is a seventh order polynomial. Now in this section in particular, we're going to study second degree called quadratic functions. Notice the definition of a quadratic function. Let a, b, and c be real numbers with a not equal to 0. F of x then will equal ax squared plus bx plus c. This will be a quadratic. We will look at its graph, which is a U-shaped curve and used extensively. They're all symmetric with respect to a line called the axis of symmetry, or simply the axis of the parabola. Notice all of the applications. All right, let's recall from Chapter 1. What does our parent function look like? Well, there's our good old y equals x squared. We're going to build everything from that parent function. Notice it has symmetry with respect to the y-axis. It is called a parabola, and we say that the axis of symmetry is the line x equal to 0. So, all parabolas are symmetric with respect to that line. The point where the axis intersects the parabola is called the vertex. Extremely important point. If we go back to our picture here then, notice where I put the little x. That's a vertex at 0, 0. That's where it turns. So, to graph a parabola with a calculator, you'll need to know the vertex and the axis of symmetry. We'll do this in the next two videos. So, let's just let Maple graph one for us here. We're going to say let's plot x squared, and just a second while we get all of the little commands in, and notice the things that we have for that. Now let's plot another one. Okay, this time we're going to plot minus x squared. Remember, it's going to be reflected over the x-axis, and we'll have similar properties as we had with y equals x squared.